Types of metamorphism. So you can have regional metamorphism, and this occurs when temperature and pressure affects large regions of the Earth's crust. This can range from low-grade to high-grade metamorphism, and this results in changes in minerals and rock types, foliation, and folding or deforming of rock layers in the area. And this is usually, again, this is something that usually happens from plate tectonics. So if you have two plates colliding with each other, you tend to get regional metamorphism over these large areas. And then contact metamorphism is a local effect that occurs when molten materials such as an igneous intrusion comes into contact with solid rock. And again, an igneous intrusion would happen if you had a plume of magma from the mantle that kind of works its way up into the crust. So this results in high temperature and moderate to low pressures because you don't really have plates colliding to create those high pressures. You can have fairly high temperatures though because you got magma there. But a temperature gradient is formed where it's hotter near the intrusion, near the igneous intrusion, and the temperature decreases with distance. So it'd be hotter, say, right next to this intrusion, and it would gradually get cooler as you got further away from that intrusion. Okay, so it's hotter near the intrusion or where the intrusion is contacting the surrounding rock, and then it gets cooler as you get further away. So metamorphic minerals that form at high temperatures occur closest to the intrusion. Those minerals that form at lower temperatures occur further away. Lava, which is on the surface of the Earth, comes out of volcanoes and stuff. But lava cools too quickly to penetrate into surface rocks. So contact metamorphism from extrusive igneous rocks is very limited to these very thin zones, if it occurs at all. So this is an example, a diagram of contact metamorphism. So our igneous intrusion is all this sort of pink area over here. So that's our igneous intrusion. Okay. And then you sort of have this temperature gradient where it's hotter over here. So here's your temperature gradient right here. So it gets hotter as you go this way. It's going to get cooler as you go back this way, as you get away from it. Over here on the far left, these are rocks that have not undergone metamorphism. So you got shale and limestone, sandstone, etc. Those are largely sedimentary rocks that haven't undergone any kind of metamorphism. And then you kind of see this range, not going into too much detail about the types of rocks that you get, but you end up with these sort of bands of different rock types that are produced as you move away from this intrusion, this igneous intrusion. You also have sort of silica that's going to kind of seep out of here. If you got any cracks or anything, the silica, again, SiO2, it's basically melted quartz. And that's going to kind of seep into any kind of cracks that are in the rock. You also have this other fluid gradient, maybe superheated water, things like that, that could also move out of this igneous intrusion into the surrounding rock. And that brings us to hydrothermal metamorphism, which occurs when very hot water reacts with rock and alters its chemical and mineral composition. So this occurs with superheated water. So mineral composition and texture of rocks can change as hot fluids migrate in and out of the rock. So you have hot water that kind of migrates in, it may melt some minerals or dissolve some minerals and move them somewhere else, and they get reformed, etc. But this is common during contact metamorphism and near igneous intrusions and active volcanoes. Okay, and again, that's because you have the silica or the silicon dioxide that has a very low melting point that's a liquid that will kind of flow out of these areas. And there's also a lot of superheated water that is mixed in with this silica. Okay, so there's a lot of hot water that's mixed in with this. This does form deposits of gold and copper and zinc and tungsten and lead, etc. These are elements that don't tend to react with other elements to produce minerals and compounds. So these tend to get left by themselves.